Hey everyone, before we get started, I just want to say thanks to everyone in the organization for this amazing conference. And also thanks to everyone that's watching me. I hope everyone is safe and sound. And well, let's go. So the idea behind this talk is to show a little of Ecto and the four main components, how Ecto.Query works, some querying functionalities, and I brought you some samples as well, so we can discuss over that. Well, my name is Willian Frantz. I am a software developer and also an Elixir enthusiast, and I've been working at Trybe. And Trybe is a web development school. We teach people into web development, and we help them find some interesting jobs. So here in the left, my left, you're gonna find my social networks in case you want to engage with me, like to talk with me, to have some conversations, feel free to do so. Ecto is a toolkit for data mapping and language integrated query. So this is not me saying that. This is actually said by the Ecto repository itself. You're going to find this description there if you join it. And well, what would I say that Ecto.Query looks like? Taking from this description, we could say that Ecto.Query is actually a bridge between our application and our database. So we're trying to connect both our database and our application. We want our application to send some data to our database, and we want our database to respond with the other data or application. And this is what Ecto does. So it's pretty much a bridge. It connects our application to our database. And it has four main components that we usually use when we are creating our application. The schema, which represents the data source into an Elixir struct. So we use to model our data inside our application. So we have a table called users, and this table might have name, age, password, and it might be associated with posts, for example. So this is how we are going to map all these entries inside of our application. And when we have an entry running on our application, that's what we're going to have. We're going to have an struct in Elixir with the name user, as you can see here, and with our data internally applied here. We have changesets, which is pretty much a set of chains. And we use changesets for applying validations, checking constraints, casting data that we received from our inputs into the data that we are applying for our database. So let's say we have an integer, a field called age, and for some reason the age came for us being a string. So this is going to generate an error changeset saying that the age can't be a string, it should be an integer, for example. So this is what changeset does for us. We have query, which is the module that we use to query over data. So we build queries the same way that we do when we are dealing with SQL languages. And this is some example. In this example, I'm just importing the Ecto.Query functionality called from with two arguments. And I'm using this functionality here, like from you in users, where this user age should be greater than 18, and I want to select its name. So I'm querying all the users that are greater than 18 years old. And we have the repo, which is the repository that communicates with the database. So nothing that we saw previous than that, the other modules, Schema, Changeset, Query, none of them actually hits the database. So every time we're dealing with those modules inside of our application, we're actually just running it inside of our application and create a script for that and preparing that to send to the database. And Repo is the module that sends those data for database. So you want to query the data, you create the query, and that query will generate a struct, and you pass that struct for Repo, and the Repo will execute your query. So here's an example. As I said, we are creating a query, and this query wasn't being executed in the previous slide, but now it is because we are doing repo.all_query. So yes, we're going to talk about Ecto.Query. Ecto.Query has two main syntaxes. They look just like these ones. So we have the macro-based query or the pipe-based query, where we have these macro functionalities where select, order by, group by, for example, and we can apply those macros in pipe. So we can pipe all these macros to create a big query for us. In this case, we're looking for users that are age 26 and we want to select their names. Here in the left, we have the same query, but built using the keyword-based query. So we have a functionality called from, and we want to select the name of all the users that are age 26 from the users table. And well, for the rest of this talk, we're going to use some examples based on the keyword. So we're not going to cover more about pipe-based. Let's say we are starting to create a query. So we just use the from, you, in user. If we just execute this query alone into the repo, like we type repo.all and we pass this value inside, we are going to select all the users, all the fields from all the users. And let's say we want to apply a where statement, like we want to filter the users that we're going to query. So we apply the where statement, and inside the where statement, we said, well, we need to filter. So we could filter the age. In this case, we could filter the name of the user. We could filter the ID of the user, and whatever else we need to filter, we could. And now let's say that we don't want to select all the fields from this table. We just want to select the name. So we can add a new statement called select, and we can apply only the fields that we want to select from this query. So in this query, we're going to select the name from all the users, filtering them by their age. So we want to select the age 26. And as you can see, we have a couple of statements here, the where, the select, and they are using keywords. So you are passing the where with this double comma, and we have this in, which is actually an operator, but something is different here. We have this from, this first from, like as we can see here. And if we have this from up here, we can assume that this is a function. So this is a function that we are calling with 3 arguments, I would say. The u in user, the where statement, and the select statement. So we could pretty much use parentheses here to clarify that this is a function calling. And now we can see that this is a function with 3 arguments. And we have these optional statements, for example, where select. And there are other two functionalities inside Ecto.Query that we could use the same way as we use from. We have the first and we have last. The first, for example, we will bring the first users from the database. It's pretty much going to select everything from users, limit 1, and in this other case over here, he's going to do the same thing, but he's going to order by the descending. So that's pretty much what it does. So we have the from, we have first, and we have last. Those functionalities, those are the only functions that we have when we are applying queries using the keyword-based query. And about the statements that we have inside the functionality. So I have already shown where and select, but we could also use the joins. So we could join tables like we are selecting from users, but since users has many posts, for example, we could apply a join with posts to get all the posts from a user. We can preload as well. Sorry. And the preload is pretty much we saying to the database that we want to bring those data within the query. So in the join, you're joining data, but you're not actually selecting that data. But with the preload, we're saying, okay, I want to preload in a way that I can select all the fields inside posts table. We have the limit, so I could limit how many data I'm going to bring from the database. We have the offset in case we want to bring limit 5 from the offset 1 or limit 5 from the offset 2. So we are pretty much doing a pagination on our data. We have the order by, group by, in case we want to order or group. We have the having. We have the intersect. We pretty much could use everything that we need to create a complex query here. We can even use windows, for example. So we could create a window and run that window over some partition, for example. So Ecto.Query is amazing and pretty complete. We could build a complex query without a problem. So let's get back to the first example, for example. So we are selecting everything from users where the age is 26 and we want to select only the name. And in this case, when we are execute this inside our IX, for example, let's say we open the IX, the interactive Elixir shell, and we type this query there. We're going to realize that this is going to output this struct for us, and struct called Ecto.Query with some data inside from you and user where. So it is creating a struct with our query. And what's interesting here is that this struct is going to be passed for the repo to hit the database and bring back the data we need. So let's say we want to compose a query. So in this first example, we're just creating a query from scratch, and this query is the whole. We are not composing it with anything. So let's say we want to break things apart, and we create a new variable called query. And this query will select everything from users where age is 26. Now we have this Ecto.Query struct. And it says only select from users where age is 26. But now let's say that we want to compose this query with a different query. So we, instead of creating a new query from users, we want to create a new query from the query we have binded previously. So look at this. We have a query selecting over another query, and we are passing only the statement select. So I want to select the name from those users. And now you can see that we are actually generating the same struct that we did in the previous slide. So this is something really amazing about Ecto.Query. We can compose queries. We can create multiple queries and we can attach them to each other in a way that we could have complex queries. For, let's say we have complex business logic and we want to query all users, but now we want to query all the active users or all the active users that has been doing something specific. So we could compose queries for that matter. We could also use some helpers in Ecto.Query. We could use like, we could use is new. Like is just querying over a substring, for example. We have this substring, ElixirConf, and I want to select all the users that have this provider into their emails. So I am applying the @ElixirConf compared to the user's email, and I will select pretty much all the users that has the ElixirConf provider email. Or let's say I want to select all the users that actually doesn't have an email, for example. So I want to is new email. So we could use these helpers to build a complex query as well. And we can even use fragments. Fragments is a way to injecting some SQL inside of our query. So when we use a fragment here, we're actually generating the same struct outside. So the output for this query would be Ecto.Query with the arguments from user where fragments and documents passport is new. And what this query is actually doing is, let's suppose that we have a documents field inside of our database, and this documents field is actually a JSON-B that was indexed using a gene index. So inside these documents, we are holding passport, we are holding social security number, for example. So we have documents of my person, and I could query over them by using these operators, which are operators from the JSON-B Postgres. So yes, in this query, I am selecting all the users. I'm selecting all the users that does not have a passport, for example. And yes, we could even use fragments for doing other stuff. Like let's say that we have a functionality that deals with dates, but for some reason, our field is not really a date and we need to convert that to a date. So we could do that by using a fragment. So we would apply the fragment, and instead of doing documents passport here, we would call the field with 2 commas and the date here. So we were casting this to a date inside the database query. So what can we take as points from everything I said so far? I guess control is something that's really important for me when dealing with Ecto.Query. It's something that I really enjoy doing Ecto.Query. We create a query, and not only Ecto.Query, but actually Schema and Changeset as well. We are creating something that gives us a struct, an Elixir struct, and we can debug that. This is not really hitting the database. Like the very time that I create a query, it's not hitting the database. It's not going for a round trip. So composability is something that I like as well. So we can compose queries, for example. We can have different contexts working into the same application. I want to select a user that is active, but now I want to select a user that is active and it is age 26, for example. So I have a query for age 26 and I have a query for active users, and I can merge them and query inside the database. Other point that's really important for me is the query vocabulary. We can create all types of queries that we want to. As we saw previously, we have windows having intersect, we have joins, and we have a lot of helpers as well. I've only shown is new and like and fragments, but we have other different types of helpers that are really helpful. And we have dynamic queries as well. Let's say we want to create a query programmatically, like we build a statement that's using a dynamic query, and we are receiving some inputs from the user, and we want that those inputs became some query. So we could do that. We could achieve that by using dynamic queries, and this is something awesome. So yes, I brought you some samples, and those are pretty simple, but I guess you can get the idea of how hard it can go, like, and really fast. So let's say we want to query over emails using like. So I want to select users with email by email. So I'm passing some string called email here, and this string might have some substring of an email, and we want to query over the substring. So that's why we are applying a like here, and we are just interpolating our string, or email string. This is pretty simple, and we are using the like helper, we are using the keyword statements, and we are passing through repo.all. In this case, I'm using repo inside this functionality, but I guess in case we want to build composability, we would have only the query inside this functionality, and this functionality would be get users with email, for example. And then we could pass this functionality inside the repo.all. So for the next example, let's say we have posts. Let's say the context that we have users and we have posts, like we have a blog, for example, and we want to get all the user posts. So I have a user ID being passed in the argument. So I need to query over the posts for this user. So we're gonna select all the posts, joining them with the users, and we want to select all the posts where the user ID is equal user ID. I'm using the pin operator here, so it doesn't try to pair matching. And I am selecting the post, all the fields of the post, and I'm applying the repo.all query. So this is still pretty simple, but we have added a new keyword functionality, which is the join. So now let's say we have user, and a user has many posts, and those posts might have many comments. So let's say we want to bring posts from user with the comments. In this case, we will select everything from posts, joining with the user, and joining with the comments. So I will query them over this user ID that I'm passing into the arguments, and I am using the preload here. So as we said previously, The preload is actually getting all these comments that we have joined and loading them inside our data structure that is going to be answered for us. So we have a post, and this post might have 5 comments, and the other post might have 6 comments. So we want to preload them in the right way. So I want to preload the 6 comments from the post 2 inside the post 2 JSON. That's what we're doing here. So now let's say that we want to get users posts recent comments. I don't want to grab all the comments. In this query, for example, if we have like thousands of comments, we would preload all those thousands of comments, and that's not something really good for us here in this context. So let's say we want to load only the recent comments, and we're going to load only the 5 recent comments. So we're going to select from post, joining with users, join with comments, and here we're going to set another join that we're going to query only. We're going to execute a sub-query where we're going to query only over the 5 recent comments. So this inner lateral join is doing our sub-query, and we have the most recent, and we are querying from comments where the post ID is the post ID that we are querying. And we are going to order by ID descending. So we want to query the most recent, so the ID must be descending. And we want to limit into 5. So we're selecting only the 5 recent comments. And we're selecting only the IDs inside these lateral join because we're going to match them with the comments that we have joined previously. So most recent ID should be equals the comments ID. And now we are applying the where filter. So the user must be the user passed into the arguments. And we are preloading the comments. So we are grabbing the 5 recent comments, and we are applying those comments to each of the posts that we brought from the database. And we are applying the repo all here at the end. So remember, every time I'm creating a query, I need to pass that query for the repo to be executed. If I don't do that, so the query will only generate a struct, an Elixir struct, and it's never going to hit the database. It's not going for a round trip. So I guess the conclusion that we could take from this is that Ecto.Query is something really unique and complete. We can build pretty much any query we want to, and we can go from complex business queries like going for the database, joining with multiple tables, doing a lot of process. We can even use the database built-in functions. So we could pass the fragment inside our query and call some built-in function from the database. There's no problem with that. And it works pretty well. And we could create dynamic queries. We could compose queries. It's something really unique. And also answering some questions, I guess, that there's no reason where I guess we would really never need to build raw queries inside Ecto. So if we're using the SQL adapter from Ecto and we are working with Postgres, for example, that's most of my experience, we would never need to use raw queries to build raw queries. We could just use Ecto.Query for pretty much everything. And yes, Ecto.Query is robust. It's good for building complex queries, composability, you have control. I guess that's it. That's the message I was trying to pass. And I hope you have enjoyed. And that's all. Thanks.